Hello guys and welcome to Python programming tutorials by Amul's Academy. So we were discussing about array manipulation, and in the previous tutorial we discussed about how we can rearrange the dimension of the given NumPy array. And today here we'll discuss about how to split and join given NumPy arrays. So first we'll discuss about joining or concatenating given NumPy arrays. So for this we can use a function called concatenate, and this function is used to join two or more given NumPy arrays along the existing axis. So let's see the syntax first. Okay, so you should mention numpy.concatenate. So concatenate is a function and it belongs to NumPy library. So we need to mention numpy.concatenate, and it contains three parameters. First one is arrays. Here you need to mention the arrays which you want to join or concatenate, and here you can mention two or more NumPy arrays. But while taking arrays, you should remember that you can't concatenate or join arrays of different dimension. That is nothing but you can't join 1D array and 2D array. Dimension of the arrays should be same. This is the first condition. And the second condition is be careful about the shape. So input array dimension except for the concatenated axis must match exactly. So we'll see the example, then you'll understand this. The second parameter is axis. So along which axis you want to join NumPy arrays, and by default value is 0, that is nothing but first axis. So in one dimension it contains only one dimension, so only one axis. In the 2 dimension it contains 2 axes. In the 3 dimension it contains 3 axes. So based on that axis you can join the NumPy arrays. So for that this parameter is useful. And you can take axis as none also. When you take axis as none, it will flatten the given NumPy arrays first, then it will concatenate that arrays. And the next parameter is out. The default value is none. If provided this is the destination to place the result, you can store the joined arrays in another array or in any other destination. So for that here you can mention out parameter for that. By default value is none. Okay, so this is about the syntax. Next we'll take the example. Alright, so here I have two 1D array. Array name is A and B. We created this array from arrange function. So now if I want to join these two array, then I need to mention np.concatenate. Next here I need to mention arrays. So I need to mention arrays in a tuple. So array name is A, B. So here next parameter is axis. By default value is 0. Because we are adding one dimensional array and one dimensional array contains only one axis, so no need to mention the axis here. Okay. And I won't take out parameter now. I'll explain you about that later. For now we'll take the default value, that is none. So next if I enter this, here we can see the joined array 1 2 3 4 0 1 2 3 4 5. So A value is 1 2 3 4 and the array B value is 0 1 2 3 4 5. So we can see the joined array here. Next we can join two or more NumPy arrays using this function. So here I'll take the example for that. Here I need to mention concatenate, and here I'll mention A, B, C and enter. Here we can see the joined arrays. Okay, so this is about how we can join 1D arrays. Next we'll talk about the out parameter. What happens if I mention the destination for the result? How to mention that? So for that I'll take this example, the first example. I'll take an array. Okay, so I'll name that array as C and I'll create the arrays of zeros using zeros function. So now I need to mention how many elements I want in that array. At that time be careful about this output array shape, because here we need to mention the exact shape. Okay, so here we can see this array contains 1 to 5, that means 4 elements, and it is till 6, that is nothing but 6 elements. So I want total 10 elements. Okay, so here I need to take the shape as 10. So now if I enter, So we created the array called C filled with zeros. Okay, it contains 10 zeros because we'll store this result in this array. That's why. Next I need to mention np.concatenate, and we are concatenating a comma b. So next out is equal to C, and if I enter, so here we can see the values. These values are in the floating point value because in zeros default data type is float, that's why. Okay, so if I check C now, here we can see. So the result will be stored in the array C also. So in this way you can store the result in another array. Okay, so this is about how to join 1D arrays. Next we'll talk about the 2D arrays. Alright, so we have 2D array here. Right, so to concatenate this, can mention a comma b. I won't mention the access and out. So it will take access as 0, out as none. So if I enter, we'll get 1, 2, 3, 4 and 5, 6. So 5, 6 is joined here. So it will concatenate according to the access 0. So we'll get 5, 6 here. So whenever you are concatenating two arrays, first check whether two arrays are of same dimension. Here yes, A is a 2D array and B is a 2D array. Okay, done. So the next is check the shape. Okay, so here the shape of this is, here array A shape is 2, 2 and array B shape is 1, 2. So we are joining this array based on axis 0. So we should check other axis, like we should check other dimension. It should be same. So for example here 2 and 2 both are same. No need to worry about the axis along which we are joining the arrays. We need to check the other dimension like this. 2 and 2 are equals, that's why it will join the arrays and will give the output. If I take axis as 1, what will happen? A comma B, and here I'll take axis as 1 and enter. We'll get error because when I take axis as 1, we are joining or concatenating the arrays, okay, along this axis. So that's why we'll check other axis, like we need to check this and this. This is not equal, that's why we are getting error here. The other axis except the concatenating axis should be same. Here it is not same, that's why we are getting error here. While concatenating, we need to be careful about the shape of the array. Okay, so if you want it to work in the axis 1 also, so then you can mention like this: a comma b dot transpose, okay, the attribute axis equal to 1. If I enter now, we'll get the output. That is because when I transpose this b, so it will interchange the dimension. So b becomes 2, 1. So now a is 2, 2 and b is 2, 1. Then when we perform this concatenate operation or function along with axis 1, okay, so here other axis is same, 2 and 2 are equal, that's why it will give the output. Okay, so you should remember only one thing: when you are concatenating the arrays, be careful about the dimension of array and shape of array. So if we have an array like this, okay, 1, 2, 3 and 4. Next another array 5 and 6. Now if I want to join this array here, okay, then I can join it easily like this: 5, 6, okay, no problem. But if I want to join that here in column wise, then it is not possible, right? I can't add like this 5, 6, okay, we can't enter anything here, right? So that's why we got error when we tried this. So when I transpose this, we'll get 5, 6, okay, it will change the dimension, then I can add here like this 5, 6. Another example, if I try to concatenate or join arrays of two different dimensions, then what will happen? So here A is 1D array and B is 2D array. So now if I try to, so we'll get error, okay, so we can't do this. Similar to concatenate function, NumPy library provides other functions also to join or concatenate given NumPy arrays. So we'll discuss about two functions here: hstack and vstack. So first we'll talk about the vstack function. So this function combines the array vertically. The syntax is simple. We need to mention NumPy dot vstack and here tuple of arrays. So here this is the tuple of arrays. We can mention 2 arrays or more than 2 arrays here. The arrays which we want to join. So this vstack function behaves same as concatenate function when we take access equal to 0 in 2D array or more than 2 dimension array. So when we take 2D array or 3D array or 4D array, this numpy.vstack function is similar to the concatenate function with access as 0. So that is nothing but vstack function combines the array along the axis 0 or the first axis. So axis 0 is nothing but first axis, axis 1 is nothing but second axis, okay? But when we apply this vstack function on 1D array, it behaves a little bit differently. So we'll discuss all of that. First we'll see what happens when we apply vstack function on 1D array. So here we have 3 array. Now if I take array A and N, you can apply this vstack function on 2 arrays or more than 2 arrays. For now I'll take 2 arrays A and N, okay? Both are one dimensional array. So I'll take np dot vstack function name. Next here I need to mention tuple of arrays. So I'll take A and N. So I'll enter, I'll get error. Now I'll try this np n and c, okay? And enter. I'll get the output. But here we can see I'll get 2D array. So here we took one dimensional array, n is 1D array, c is 1D array, but we got 2 dimensional array as output. So when we apply this vstack function on 1D array, for example here we have one array, next I have another array. Now if I apply the vstack function on array A and array B, so now it need to concatenate this array vertically along the axis 0. So what it will do is, it will convert this 1D array to 2D array. For example, actual shape of this is 4, but it will take it as 1, 4. It as 1, 5. Next it will start joining. For that it will check whether both the arrays are same dimensions. Yes. So next what it will do is, vstack is nothing but along the axis 0, right? So it will do the operation along the axis 0. So it will check the other axis to concatenate or to join the arrays. The array except the concatenating axis should be equal. So that is nothing but 4 should be equal to 5. It is not equal. That's why we got error here. But in the case of n and c, both the elements contain same number of elements, that is 5. That's why we got the output. So in 1D array, when we apply vstack function, array must be of same shape. Array must contain same number of elements, first point. And we'll get 2D array as output. Okay, so this is about the vstack function on 1D array. And in the 2D array, np.vstack, and here I'll mention A, B. A and B are the 2-dimensional arrays. So now if I apply this, we'll get same output as this concatenate function. Here axis by default is 0. Okay, so that is nothing but this vstack function behaves same as concatenate function with axis 0. Here we can see the same output. So vstack function behaves differently in 1D arrays, but in 2D array, 3D array, 4D array, it behaves same as concatenate function. It actually calls the concatenate function. That's why we got same output, right? So vstack function combines the arrays vertically. Next we'll talk about the hstack function. So this function is used to combine the arrays horizontally. The syntax is simple. Should mention numpy.hstack and here tuple of arrays. And here you need to remember one thing. This hstack function behaves differently in 1D array and 2D, 3D, 4D arrays. In 2D, 3D, 4D arrays, it behaves same as concatenate function with axis 1. So this hstack function will combine the arrays along the axis 1. It is same as concatenate function with axis 1. But in 1D array, it will combine the array based on axis 0. So I'll show you the example. Okay, so if I perform np.hstack here between a and n, we'll get output. Okay, if you perform nc or ac or anc, we will get output because it will join the arrays along the axis 0. When we perform it on 2D array, hstack, so here array name is a comma b. Sorry, I should mention b dot t because we want transpose of that, right? Like this. See, this concatenate function with axis 1 is equal to this hstack function, right? This vstack function. So when we apply vstack function on 1D array, arrays must be of same shape, okay, and we'll get 2D array as output. In the 2D, 3D, 4D arrays, it behaves same as concatenate function with axis 0. And coming to the hstack, 1D array can be of any type. It will join the arrays and we'll get 1D array as output. And in the 2D array, 3D array or 4D array, so it behaves same as concatenate function with axis 1. Okay, so this is about the joining the arrays. Next, let's talk about splitting the arrays. To split the arrays, we can use split function. So it will split the given array to multiple sub arrays along the given axis. So the syntax is, should mention NumPy dot split, and here you need to mention the array which you want to split, the main array. Next here sections, how many sub arrays you want, and here axis, by default it is 0, along which axis you want to split the array. Okay, so let's take the example. So let's take 1D array. So here I need to perform np.split and I need to mention the array name is A, and I need to mention how many subarrays I want. So here there are total 9 elements in the array A because I took range as 1 to 10, so we'll get 9 elements. So if I mention I want 3 subarrays from this, if I enter, I'll get array 1, array 2, array 3. Okay, so be careful about this sections. If I mention 4 here, we'll get error because we can't split the values or the elements in the array equally. There are 9 elements. I can't divide this 9 elements equally in 4 parts. Okay, that's why I'm getting error. So be careful about this. Otherwise we can split like this, right? Next, in the 2D arrays. So in the 2D arrays, if I perform np.split A and I want 2 parts, if I enter, here we can see array 1, 2, 3, 4, 5, 6 and array 7, 8, 9, 10, 11, 12. We get 2 arrays in axis 0. You can give axis 1 also here. By default axis is 0. You can give axis 1 also. And there is other 2 function called as hsplit and vsplit. So here numpy.hsplit array and section. Here in this hsplit, axis value will be 1. So it will split the arrays horizontally. That is nothing but in along the axis 1. Axis equal to 1 along the second axis. And another one is numpy.vsplit array and section. Here also it split the arrays vertically, that is nothing but along the axis 0. Okay, so here np.vsplit, if I mention just A and 2 and enter, we'll get the same output. Here also axis is 0, here also axis is 0. Okay, so there is no parameter called axis in the vsplit function because it will split the arrays along the axis 0. or the first axis. So now I want to perform the split operation based on axis 1 or h split. Then I can mention np dot h split a and 3. I want 3 subarrays. Okay, so like this I'll get 3 subarrays. Okay, or if you want you can perform like this also, split a 3 and you can mention axis as 1. Okay, you will get the same output. Okay, so this is about how to split given NumPy arrays and how to join given NumPy arrays. So that's it for now guys. Thank you for watching. Don't forget to subscribe to my channel. I will meet you in next class. Till then, take care.